Cube roots. This is read the cube root of 64. A cube root looks like a square root. The difference is that little 3 right there. The 3, or other root, is called the index of a radical. Square roots have an index of 2, but it's not usually written out. Remember, an index indicates how many of each number or variable would allow taking a perfect root. A cube root is looking for groups of 3, just as a square root is looking for groups of 2. The cube root and the cube cancel each other out. So if we have the cube root of 125, we could rewrite 125 as 5 cubed. And then this cube and that cube root would cancel out, leaving us with 5. Here's some more examples. 8 can be rewritten as 2 times 2 times 2, which is 2 cubed. Then the cube would cancel out with the cube root, leaving us with 2. Here, 216 can be rewritten as 6 cubed. Cancel out those cubes, and we are left with 6. The cube root of 1 is just 1, because 1 cubed, that cancels out with that, leaving us with 1. And negative 27 can be rewritten as negative 3 cubed. The cube cancels with the cube root, leaving us with negative 3. This is all right to do because since this is an odd number, we can have negative signs in there. Let's try these. So we have the cube root of x cubed. So if we cancel out the cubed, cancel out the cube root, we are left with just x. Here we can rewrite this as the cube root of d to the 4th power cubed. Cancel out the cube, cancel out the cube root, and we have d to the 4th power. Here we can rewrite m to the 24th as m to the 8th power raised to the 3rd power, because 8 times 3 is 24. Then we would cancel out the cube and the cube root, and we are left with m to the 8th power. And there are the answers. Notice the cube root of negative 27 is negative 3, whereas the square root of negative 16 is 4i, which is not real. Roots of negative numbers will produce real solutions if the index is odd. So if we have an odd number here, we can have negative numbers, and that's all right.